Hello everyone and welcome to this video. Our objective today is that if I give you the graph of a linear function, you can create a story, equation, and table that matches it. This is our third part in this video series, and let's get started. All right, hopefully these don't take too long. Let me move myself out of the way. I do think this might be a little bit of a longer video, but our goal here is to create a story, equation, and table that represents this graph here. Here I have a linear graph. I know it's a linear function because it goes in a straight line. And so anytime I have a linear function, I know I'm using the equation y equals mx plus b, where x and y are constants, and I need to find m and b. So let's do that here. M equals b equals. Okay. B is on the graph is the y-intercept, all right? And m is the slope, the rate of change. So to find b, the y-intercept, which is where I intercept or cross the y-axis, is pretty easy. Where does this line cross the y-axis? It crosses it at 2. So the b, the beginning, the slope, or sorry, not the slope, the y-intercept is 2. The b is 2. Now I need to find the slope because I need both parts. And that is rise over run. All right. So how much do I rise to get from here to here, right? My next point. How much do I rise? I go from 2 to 3. From 2 to 3, well, I went up 1. Now the next one is a little tricky. You got to watch your tick marks. The first tick here is not 2, or is not 1. It's 2, right? There must be a 1 somewhere in here. So I did not go over 1 just because I went over 1 tick mark. I went over 2. We went from 0 to 2, and to go from 0 to 2, our run is 2. So we have a slope of 1/2. So to put these into the equation now, I just have to plug in. I have y equals mx plus b, and I just plug into there. Where there's an m, I'm going to put 1/2 for the slope. And where there's the y-intercept b, I know it's 2. And so now I have this equation, y equals 1/2 x plus 2. This equation shows me that is the exact same thing as this line. They're the exact same thing, just shown differently, just like water and ice have the same chemical makeup, but they're in different forms. Same with this equation and this graph. If you guys said graph this equation, you would make this graph, right? They're the same thing. All right, so now we have the equation. We need to make a story. So we have a lot of practice with this at this point. I have something where the b is 2, so the y, we're beginning at 2, and it's changing because there's a rate of change, the slope of 1/2. So I could do a story like a squirrel is 2 feet up a tree. It goes up a 1/2 foot per second. So it starts at 2 feet above because it's positive 2, and it goes up 1/2 a foot per second, right? I could do, and let's just do this one. I could do Luis has $2. Starts with $2. He gets, what's half of a dollar? 50 cents. Right? He gets 50 cents a day. So this story could easily be represented by this equation here, where Luis has $2 and he's gaining half a dollar or 50 cents a day. All right. And now I need the last form, which is a table. Do it here in purple. I'm going to do it twice just to show you there's 2 different ways here. All right, so I have a table, x and y. I could use my story to make the table. I could use my equation to make the table, or I could use my graph to make the table. If I use the story, all right, so think about the x as days. After 0 days have gone by, how much money does Luis have? He's got $2. He starts with $2, so after 0 days, he's still got $2. After one day, how much money does Luis have? Well, he's got $2.50. Right? After 2 days, because he's getting 50 cents a day, he's getting half a dollar a day. Now he's got $3. All right. So we could keep going, but I'm out of space there, so I'm just going to leave that for now. What if I did this table in a different way? Another way I could do this table is if I said x and y, and I just listed points on this graph, right? The table is just points on the graph. So I could say, all right, here's a point. Where am I at? Well, x is 0, right? I'm at 0 on the x here. And where am I at on the y? I'm at 2. I could do this point right here. Where am I at on the x line? I'm at 2. Where am I at on the y line? I'm at 3. Look at these, how these points are the same. Here and here. Look, 0 and 2, 0 and 2, 2 and 3, 2 and 3. They're the exact same because it doesn't matter how I do it because they're all the same thing. They all show us the exact same information. There is a point on here, right? It's just not shown. 1 and 2.5. So that point isn't not there. It's just we weren't given the point for that spot, right? So this point is still here. So just like that, we have it all done. We have our table, we have our story, we have our equation, and we were given our graph. So we have all 4 ways to show this mathematical relationship. All right. Let's move on to the you-do here. Let me move myself a little bit. I'll go over here this time. Create a story equation and table that represents this graph. Go ahead and pause, do the you-do on your own, and then unpause to check your work. Okay. Hopefully you're unpausing because you already completed it. I'm going to go through this pretty quick so this video is not too long. First step is I need an equation. This is a straight line, so I know my equation is y equals mx plus b. I need to know what my slope is and what my y-intercept is. My y-intercept is where I cross the y-axis, or f of x. They're the same thing, and that's at 5. And my slope is rise over run. So how do I get from this point to this point? Well, to get from 3 to 2, one sec. No, you're good. I can pause. Sorry, just got interrupted real quick. To get from 3 to 2, I go down 2, right? So I can put a 2. Oh, I can shrink. Let me shrink myself a little. Oh, all right. I can put a 2 right here, right? Because we go down 1, 2. But since it's down, it should be a negative 2. And then I am going over how many? 1, 2, 3. 1, 2, 3. So my run is 3, right? Rise over run. So I went down 2, so I use a negative 2. Over 3. My slope is negative 2/3. I'm just going to plug this into the equation. Y equals negative 2/3 x plus 5, because these are just replacing. All right, so now I have the equation. Again, I said I was going to move this through a little quickly. Now I need a story. So if something starts at 5, it's changing by 2/3 or going down by 2/3. So I'm gonna use elevation instead of money, since fractions isn't really how we talk about money. I'm gonna say Derek is 5 feet above ground. He's above ground because that's a positive 5 as the beginning, right? He goes down 2/3 a foot per, let's say Derek is slow, per minute. All right. So now I have a story. So make sure your story that you wrote has something starting at 5 and going down by 2/3 the rate of change. So your story does not need to be the same as mine. The last is the table. I think it gets a little tricky to use fractions from my story. So I'm actually going to use my table to make my points. And this one's even easier, right? It showed the points. So this is 0, 5, 0, 5, right? I'm at 0 on the x, 5 on the y. This is 3 comma 3, 3 comma 3. This is 6 comma 1, 6 comma 1. And just like that, I've created the table because the table is just points on the graph. That's all that is. So don't let that trick you. All right, so now we have all 4. We're done. Hopefully you got that right. We're going to do one more. Or 2 more, I guess. All right, example 2. This time I'm given a graph that already has some things labeled. So it's something about a banana tree here. And how do I move this? Oh. Sorry, I just need to move this out of the way. There we go. No. Come on. All right. All right. So we have a banana tree here, and it shows me some information about this banana tree. Where I have the height in inches in the y-axis and days on the x-axis. And so I'm actually going to start with the equation here. So we know it's a straight line, so I'm going to be using y equals mx plus b. So let's think about it. First thing I need to know is the beginning, right? I need m and b, so m equals b equals. B is easiest to start off with. Where do I begin at the y-axis? Well, I begin at 8. And where do I begin? And what's my rate of change? What's my rise over run? All right. So to get from this point to this point, how much do I rise? I go from 8 to 12. How much do I rise from 8 to 12? I rise 4. And to get from 0 to 1, I'm only going over 1, so my slope is 4 over 1, or just 4, right? 4 over 1 is 4. So now I can write my equation. I can say y equals 4x plus 8. But I can do even better than
Good morning,
this.
Mr. Davis. I need some gloves in the main office, please, for the cafeteria. Like 3 boxes. Thank you so much. Have a great day.
I can do even better than this, right? Because on the y-axis, this is the y-axis, the vertical axis, I have height. So I can say really h, because that's height. And on the x-axis, I have days. What variable could I use for days? I could use d. So I could create the equation h equals 4d plus 8. Right? This would probably be the best possible equation. Ignore how bad that 8 is for this graph. All right, so this graph tells me the same information as this equation here, that there's a banana tree that starts at a height of 8 inches, and every day it's going up 4 inches. So now that's the story, right? That is the story. We don't write our own story here. We're given the story of this graph. There's a banana tree that starts at 8, and every day it's going up 4 inches, right? That's what this 4D means here. So a banana tree starts 8 inches tall. It grows 4 inches per day. All right, so we can use graphs to figure out what's going on. What story is being told here? Well, this graph is telling us a story. It's saying there's a banana tree that starts at 8 inches, and every day it goes up 1 or 4, right? So every day it's going up 4. So by day 3, it's already 20 inches tall. All right. So the last step here is to make our table that shows the relationship between not just x and y, right? But it's really days and height. So after 0 days, what's the height of this banana tree? Well, it's 8. Right? After 1 day, well, it's going up 4 inches each day. Hopefully you can figure out that mathematically. It's 12. But if you, for some reason, got stuck on the on the math, here it is, right here. 1 day, 12 height. 2 days. It goes up another 4 inches. That's 16. But again, if you get stuck on the math, boom. And if I wanted to jump and show this point right here, I could do this point, which I can't really see because it's blocking. But it looks like we're at 5, 6, 7, 7, and 36. And I could keep going. You don't have to. So now I was given this graph and I was able to tell a story with it. A banana tree starts 8 inches tall and it grows 4 inches per day. I was also able to create an equation that represents that relationship. And I was also able to create a table. And so this is getting more and more to high level stuff that I hope you can accomplish with math. Okay. Last one. Last you do. Oops. All right. So make a story, equation, and table for this. This is a you do. Go ahead and pause and get started. Okay. Hopefully you're unpausing now because you finished it. I'm going to go through this really quickly because this video is much longer than I wanted it to be. All right. So I have a graph here. It's a straight line. So I'm using the equation y equals mx plus b. To make the equation, I need m equals b equals. Where do I begin here? At the y-intercept, I begin at 82. At the my slope, how do I get from this point to this point? It looks like I go down 1, 2, from 80 to 82. So my rise is -2 because I go down 2. And how many do I go over? Well, it looks like I go over 1. Even though there's 2 tick marks, I'm only going over to 1. All right, so it looks like my slope is -2/1 or just -2, right? So now I can write my equation. I can plug in. I'm going to plug in y equals -2x plus 82. But I can really do better here because y, what it really is the temperature in Fahrenheit. I'm going to use T for temperature equals -2x plus 8, or sorry, not h, not x. And for my x, I can also plug in, all right, because I have time in hours. So I can, instead of x, I can put an h plus 82. So my real equation here is that the temperature is equal to -2 times the amount of hours plus 82. And so what's the story here? What story is this graph telling me? Well, it's telling me that the temperature is starting at 82 degrees. And every hour, it's going down 2 degrees, right? After 1 hour, now it's 80 degrees. So that's the story it's telling me. I have starts at 82. It's going down the slope of -2, right? So this tells me where it starts. This tells me how it's changing. So I'm going to write the temperature is 82 degrees. It goes down 2 degrees per hour. All right, so the temperature is 82 degrees. It goes down 2 degrees per hour. That's the information I'm getting from this graph. All right, last is the table. I don't want to really use X and Y. I'd really like to use hours and temperature, right? So after 0 hours, what's the temperature? We could look at our story. Well, it starts at 82. Could also use look at my graph right here. After 1 hour, what's the temperature? Well, it tells me on the graph, right? It's 80 degrees. But also the story really tells me it's going down 2 degrees per hour. So after 1 hour, it should go down 2. After 2 hours, it goes down 2 more. After 3 hours, it goes down 2 more. And voila, we have our table, graph, equation, story, all from this. I hope you enjoyed this video. And if, like always, you know how to find me if you have some questions.